Hi everyone, Teacher Yong here from Yong Academy. So there's for the students that are taking IGCSE this chemistry this semester, there should be a last paper, which is paper 2 left. So today we'll be trying out one paper 2. And yes, let's jump straight into it. Okay, so let's start by looking at the question. So this one is extended paper 2, May, June 2024. So we have 45 minutes, so let's try to finish it within 45 minutes. Okay, so let's jump straight into the first question. Which gas has the slowest rate of diffusion? Okay, so normally when we see this, especially when we see this word diffusion, and when we compare whether they are faster or slower, we look at the mass, either the atomic mass. So if we look at the periodic table, all right, let me just open one of the periodic table. But I believe we also have it at the very end. They also include the periodic table. Yeah, it's also here. But I'll just open another one so that it's easy to refer. Okay, so this one here. So hydrogen is 1, as we can see here. So H2 means 2. So what I encourage students to do is just write a 2 below or beside it, and then NH3. So N is this one here. So the mass of nitrogen is this 14. So 14 and then 3 hydrogen, so it's 17 because each hydrogen is 1, as we checked in A. CH4, C is 12, as you can see here. C is 12. So 12 plus 4H, 16. And then CO2, C is 12, which we just checked, and O is 15.999. So if we round it up, it's 16. But don't worry, normal periodic table will give it as a whole number. So this is carbon is 12, oxygen is 16. So, well, if we can't do it, let's just write out the working. Plus 2 bracket 16 equals, okay, so 2 times 16 is 32, added together 44. So clearly this one is the highest, so it's the heaviest. If it is the heaviest, it diffuses the slowest because it's, well, you can imagine it's fatter. Okay, I think that's clear enough. Now let's move on to question 2. Which statement about the positions in the periodic table are correct? Elements in the same group have similar chemical properties. Yes, correct. Because in the periodic table, which is this one here, for example, group 1, all have 1 valence electron. Group 2 has 2 valence electron. And their chemical property depends on how many valence electron they have. So yes. Elements in the same period? No, okay, because all of them have different valence electron, because period is going horizontal. Group is going from up to down. Period is from left to right. So it's not correct. Element in the same group have same number of electron shells? No. Period has. Elements in the same group have the same number of outer shell electrons? Yes, because what we say, valence electron, which is the final layer. So clearly 1 and 4 should be very easy, all right? Okay, number 3, which statements about isotopes are correct? So isotopes, even before we read the question, students should know definition. Especially, they should have studied this for their paper 4. Same number of protons, different number of neutrons. Okay, so anyway, same number of protons. Same chemical, no. Let's just leave that for now first. Where's the other one? Same relative mass, this definitely not, because they have different number of neutrons. Neutron adds to the mass. And then Oh, wait, sorry, I read wrongly. This one is different. Ah, okay, this one has different elements. My apologies. Different elements. So yes, they have the same number of protons, but they are not different elements. They are the same elements. So there's a mistake in front. So it's out. So students, please be careful. Sometimes you just read this part here. It might be correct, but there's one word in front that makes it wrong. All right. Isotopes are same element, yes, because they have the same number of proton, and if they have the same number of proton means they have the same number of electrons, which means their valence electron is same. If the valence electron is same, their chemical property is the same. 3, they are atoms with the same, no, because they have different number of neutrons, and neutrons adds to the mass. So when you have more neutrons, you have a heavier weight. Isotopes of the same element have the same, yes, because their electron number is same. So the answer is C. Should be rather easy. Number 4, which diagram shows the outer molecule, outer shell electrons in a water? So H2O. So all of here, these answers have 2 hydrogen and 1 oxygen. So yes, that looks correct. Okay, so I think this is rather easy because if we look here, hydrogen is in group 1, so it has 1 valence electron. Oxygen is in group 16, so it should have 6 valence electron. Sorry, 4. I mean, hold on. Oxygen has 8 protons, means it has 8 electrons. Then the first layer we can put 2. Second layer we can put 2, and then we have 6 left. So it needs 2 more electrons. So one moment, looking at here, 8, 2, 6. So it should have 6 valence electrons. So here, only boy and cat shows that oxygen has 6 valence electron. So it should be C, because hydrogen, as we just learned, it only has 1 electron on the shell. But here shows that hydrogen has 2 valence electrons. So that's out. So it can only be this, because the black color dot represents the electron of the hydrogen, while the X represents the oxygen ones. Okay, let's move a little bit faster. Oh, and exam students also, do remember that you only have 45 minutes. So on average, one question should take 1 minute. Okay, number 5. Which substance have a hard and have a high melting point? So this definitely has hard because it's a diamond shape, and it definitely has a high melting boiling point. Okay, this one here is graphite. Let's write it out. So students should have learned graphite in their syllabus before. It's one of the complex molecular structures. So it does have a relatively high melting and boiling point, but it's not exactly hard. So we are gonna cross this out from our answer. This one is also in the shape of a diamond form, so it will be also hard and also have high melting and boiling point. So answer should be donkey. Number 6 here. Information about W, X, Y, Z. So we have different melting boiling points, whether they can conduct electricity. So they say W is graphite. X, so let's just write W on top here. X is polyethylene, Y is sodium chloride, and Z or Z is silicon oxide. Okay? Oh, but not in that order. So that means one of this is like graphite can be W, X, Y, or Z. It can be anything, but the choices are these 4. Okay, all right. So graphite is what we use in the electrolysis as our electrode. So it definitely has to be able to conduct electricity. So here, and in a solid form, because electrode is solid. So here, which one conducts when solid? Only one. So this definitely has to be graphite. So I'm just going to write short form here. And then polyethylene, okay. we know that polyethylene cannot conduct electricity. So for now, we'll just leave it on one side first. Sodium chloride. Yeah, sodium chloride conducts electricity, but okay, it's basically a salt, so it should conduct electricity. um, when molten, because it must be in liquid form, then only the electrons, sorry, the negative ion can flow freely. It cannot conduct when it's solid. So this one definitely has to be NaCl. So let's write it beside. Okay, so then the only remaining is polyethylene and silicon oxide. So silicon oxide and polyethylene both does not conduct electricity. However, polyethylene is what we call a covalent bond. It's what we learned in our final chapter. So maybe we just write here poly, and then this one will be silicon oxide. Okay, so polyethylene is covalent bond. Covalent bond cannot conduct electricity no matter what. However, silicon oxide should be able to conduct, but not when it's solid, because when we put it into water, we mix it with water, it will produce negative ions and it will be able to conduct. So, but this one says does not conduct when solid. So yeah, that should help us find the answer. So the answer is donkey. All right, let's move on. Number 7, the structure of glycine is shown. Okay, so they drew it out for us, so no need to panic if you do not know. Okay, this is something that they just show us on the spot. So the formula, the chemical formula of glycine, so it has 2 carbon, so it has to be C2. So it can either be B, C, or D, because there is also 2 carbon in the donkey. 2 oxygen, so yes, B, C, D again, all 3 meets the requirement. And it has to have 1, 2, 3, 4, 5. 5 hydrogen and 1 nitrogen. So this is correct, this is correct. This is correct as well. Okay, then the next one here is the number of different elements in glycine. So elements is like carbon, is one type of element. So 1, 2, 3, 4. So this is out. These 2 are correct. All right. So then we have to choose the better answer. So boy and donkey both is kind of correct. All right. But we have to choose the better answer. Okay, so we look back at the question. They are talking about the formula. So formula, the exact uh way of writing, the better way of writing it is the one in B. Let's just double check donkey. I missed out something. You see here, this one here, it is CH, but actually here is CH2. That's 2 hydrogen. But here they only write 1. So because of that one small little mistake, donkey is out. All right. So be extra careful when you do MCQ, especially for extended. They love to put in all these small little traps. Okay, number 8. All right. So number 8, the incomplete equation for the photosynthesis is shown. So looks like we just need to balance the equation. Okay. And gives the empirical formula of compound P. So please remember, empirical formula is the smallest possible combination. So like maybe we know that C6H12O6 is what we will get, right? But that will not be the empirical formula because the ratio is 6 to 12 to 6. When we say empirical formula, we need the lowest possible number. So it should be 1 to 2 to 1, just like how we make a fraction the simplest form. We do the same for this ratio. So now we come back here. So definitely this and this will be the correct answer. And then now we want to see that which one has the correct moles. So let's try to balance this. So we have W, X, and Y. Okay. So there's two ways to do this. Either you balance it or you already memorize the equation for photosynthesis. So let me just get to show you all the photosynthesis equation. So students should be memorizing this, all right, for their exam. So if you have memorized this, it shouldn't be too difficult. Okay, let me just minimize it. Or you can even look at it here, all right? So this will be the formula. So if students memorize this, 6, 6, 6, right? All of it is 6. If the students can't do this, then you have to do it the difficult way. You have to literally write this out without the number, right? Just get an extra paper from the teacher and then write this out. And then you have to ask yourself, how many oxygen is going in? How much is coming out? And then like how to balance it. All right, so we won't go too in-depth into balancing equation. Just memorize it. So it should be the same number. So therefore the answer should be A. That's how we do number 8. Number 9, the concentration and volume are known. To find the mole. So we want to find the mole, number of mole, but what is given is the concentration and the volume. So if students have memorized before, the concentration formula, there are two types of concentration, mole over volume and mass over volume. In this case, clearly, because they're talking about mole, it will be mole over volume. And then they tell us that the concentration, let me change my color, the concentration is given and the volume is given. Looks like, oh wait, this one is giving for the alkali. So there's deeper to that. This one is giving the information for the alkali. So we get the mole of the alkali. And then we want to calculate the number of mole of acid needed. So do be very careful. This one here is talking about acid. The other one is talking about alkali. Yeah, so it's a little bit tricky. Okay, so we can get the mole of the alkali. So the only thing that connects the mole of the alkali to the acid is the equation. Because in the equation, we can see how many moles of this acid can react with how many moles of the alkali. So then we can use the mole of the alkali to connect it to the acid using the equation. The rest will not really help us. All right, so let's move on to the next question. Which statement about electrolysis is correct? So electrolysis is the one where we connect electrodes and then there's the electrolyte, or sometimes mixed with water, sometimes molten form. Okay, so let's just read A. Electrons, so do be careful here. It's normally very important for a student to choose the most accurate answer. So sometimes, I mean, it rarely happens, but sometimes there might be a slightly correct answer and the more accurate answer. Anyway, let's look at 10 first. So electron moves through the electrolyte from the cathode to the anode. Move through the electrolyte from the cathode to the anode. Okay, so cathode is the negative side. Anode is the positive side. It is true that electrons flow from negative to positive, which is from cathode to anode, because it's electron, not electricity. If it was electricity, then it flows from the positive to the negative, which is anode to cathode. However, it does not flow through the electrolyte. It flows through the wires to the cell, or what we call the battery. And then, yeah, it flows through there, not the electrolyte. Electrolyte is the liquid that we have underneath. So sadly, this out. B, electrons move in the external circuit towards the cathode. Yes. Okay, so when they say external circuit, then yes, it's the top. Like we have this like that, and then like that, and then this is our electrode. So it does flow through the wires, or in this case, they call it the external circuit. All right. C, negative ions move in the external circuit. Oh, no, negative ions is the one inside the electrolyte, which is our liquid inside here. And if it's in the liquid, it can only move in the liquid. So it's not in the external circuit. It should be the electrolyte. So this thing here is wrong. So C is out. Donkey, positive ions move through the electrolyte towards the anode. No, positive ion moves to the cathode because the negative attracts the positive. So positive will not flow to positive. They will repel each other. So I think the answer is quite clear. It's B. Now let's go to question 11. Aqueous copper 2 sulfate is electrolyzed using copper electrodes. What is the half equation for the reaction? So copper 2 sulfate. So the easiest is we just draw out our anode and cathode. And then we list out whatever that we have. So Cu will get Cu2 plus will get attracted here. And because it's aqueous, there's also water, so there's also H plus. And then for the anode side, we have OH minus and SO4 2 minus. So what's the half reaction at the cathode? So cathode is the negative side. Negative side, who will get chosen? So if you have the electrochemical series, copper is lower than hydrogen ion. And please remember, in electrolysis, we choose the lowest ion. Okay, so Cu2 plus. Do be careful. The one that we want to choose is Cu2 plus. Oh, hold up. Sorry, it's using copper electrodes. So if we are using copper electrodes, yeah, Cu2 plus gets chosen here. But if it was at the anode, then it would be Cu, because copper is in the electrode itself. It will, the copper will receive the electrons first, so it will be the one chosen instead of OH minus. So this answer here is donkey. So it's just a small trap, all right, to confuse students. Number 12, colliding particles must have at least the activation energy, which they show us here, EA, before they can react. Yes, correct. Right? That's literally what the activation energy means. They must hit each other at a certain energy, only they can stick together. If not, they will not be able to react. Okay, let's look at next. EA is for exothermic. Oh, the activation energy is always greater. Nope, not necessarily. Because okay, so exo and endo. The activation energy is from here coming down here, or from here going up here. So like activation energy is like the difference. So the difference between the energy can be big, can be small. There's no such thing as like, if it's exo or endo, it has to be bigger than the other. There's no such thing. EA is always activation energy is always endothermic. Yes, because activation energy is something that we absorb. So when you absorb energy, it is endothermic. So actually the exact way of drawing is more, let me see. Okay, maybe we can draw it down here like that. So like this is the activation energy, and if it's dropping down, there's like this small little bump, and then it only drops down. So this small little bump always goes upwards, and if it goes upwards means it absorbs energy. Absorbing energy means endothermic. It doesn't mean that the reaction is endothermic, it just means that activation energy itself is endothermic. So do be careful on that. Number 13. A student adds excess magnesium ribbon. Okay, 10 cm cube and 0.5 mole per dm cube. So first thing first is we need to remember that the conversion from cm to dm cube. So 1 dm cube equals 1000 cm cube. Let's see what the graph is asking. All right, the hydrogen gas produced is collected and is measured every 10 seconds. The experiment is repeated with 5 cm cube of 0.5. So like we can see here, the concentration is the same. The only thing different is the volume. So the volume halved. Is repeated, added to 5 cm cube of water using the same mass. So the difference is the volume and the water. So, okay. Which line on the graph shows the result of the second experiment? So the original experiment is this one here. So when our volume is halved, it should be half. The concentration decides how fast they react. So since the concentration is the same, the chart going up should be the same. So it shouldn't be C because they reach the final endpoint at the same time. However, this one is slower. We can see that the curve is slower, so that doesn't make sense. Donkey makes a little bit more sense. And then because the volume is halved, the final product should be halved. So the only answer is C, because like this one is cutting at 120, this one is cutting at 60. So like the only one where 120 drop down to 60 is donkey. So donkey is our answer because the volume is half, but the concentration is the same. So the curve going up must roughly be the same, the shape of it going up. Anyway, let's move on. Number 14. The equation represents the reversible reaction. Which row describes the condition that produced the greatest yield? Okay, so basically this one is a reversible reaction. So students, make sure to study about this. So we want ethanol. So ethanol is this one here. We want this one to be the maximum. We want the yield of the right-hand side to be the highest. So on the left-hand side, there's 2 mole. On the right-hand side, there's 1 mole. So for pressure, if we want it to be on the side with the lesser mole, we need to have a higher pressure. So it's either C or D. And then test. One moment. Okay, so let's continue. So when we want the one with the lower side, for pressure, we want the higher pressure. I mean, for now, we can just memorize it, but actually there's an explanation to that. So hopefully students have learned this, all right? But if you didn't, just memorize the site with lesser mole needs higher pressure. And then for temperature, we need to see the forward and backward, which one is endothermic and which one is exothermic. So for this one here, if we want our ethanol to be maximum, it has to be the forward reaction. We want the forward reaction to be optimized. So okay, we can look here. Delta H is negative. So when delta H is negative, that means that when delta H is negative means it's absorbing, exothermic. So if it's exothermic, all right, that means that the forward reaction here is exo. And if the forward reaction here is exo, that means it releases heat. And then the bottom, by default, the bottom will be endo. That means the backwards reaction. So if the forward reaction is exo, we want the temperature to be lower. We don't want it to be too high, because if the reaction temperature is too high, the endothermic will end up happening more. And then the equilibrium will shift to the left-hand side. So therefore, we choose C because we want the temperature to be lower. Why? Because when we read the top here, they say the reversible reaction between ethene and steam, and they say delta H is negative, which tells us that the forward reaction is losing heat. Losing heat means exo, because remember, when we say delta H is the heat energy in the product and reactant itself. In the product and reactant itself, the heat energy is decreasing, but the surrounding temperature is increasing. So try not to get mixed up between these two. Number 15, which row identifies the pressure and the catalyst used for the conversion of sulfur dioxide to sulfur trioxide in the contact process? So this one students have to memorize, all right? Okay, let's see. Let me just pull out the equation. So this one here is an example. So let me just minimize it a little. So here, so students should memorize this. So if you can see here, vanadium 5 oxide is the catalyst. So it's either B or donkey. And then the pressure is 2 atm. So therefore the answer is B. Right, so this one is more of a memorizing question. So just take note of that. Let's delete that. Okay, one moment. Okay, let's go on to 16. Which equation shows a redox reaction? Redox reaction means there's oxidation and reduction. So students need to memorize oxidation and reduction can either mean someone gaining an oxygen or losing an oxygen, or someone's oxidation number, which means their charge increase and someone's charge decrease. So, let's take a look here. Okay, so let's look at some examples here. So like you see here, Ag is combined with a negative because Ag is the positive, NO3 is the negative. So right now, the charge of Ag is +1. Coming out is still combined with someone else. So the charge is still a +1. So the charge did not change. The charge have to change for us to call it a redox reaction. So there's no changing. And even if we do for NO3, Na, and Cl, going in, they have a charge. Coming out as well, they have a charge. So it's not A. B. Okay, so for B, it's more of like, okay, true, this P, it combined with the oxygen, true. But it still has a charge. P here and the P here, it still has a charge because it's still married to something else. And also, this is not the normal reaction that we look at. It's a very weird reaction, especially when we have H2O here breaking up. So this one, normally we do not consider it a redox because a redox is when we have a plus and a minus, and from a plus, it turned into a zero. That means it come out from the combining. So this one here would make a little bit more sense, even though the plus and minus doesn't really make a lot of sense here because there's H2O, and H2O is not ionic. It's more towards covalent. However, this Fe, because at the beginning I said that either it has a plus and minus change, or someone gains an oxygen and loses an oxygen. So in this case, the clear person that loses the oxygen is hydrogen, and the clear person that gains an oxygen is Fe, which is iron. So the answer is C. I hope that's clear. But don't try to confuse yourself too much. Let's move on to 17. This equation here, so we can just look at that. Which statements about this is correct? The oxidation number of aluminium reactant is +2. Aluminium reactant here is this one here. Before it react, it haven't combined with the negative yet. So it should not have any oxidation number yet. But it will have, because coming out, it already combined with someone else. However, going in, it haven't combined yet. And even if Al should have combined with someone else, the charge should not be +2. It should be +3. So this is just wrong on many levels. The oxidation number of the aluminium product is +6. No, the oxidation number of aluminium in a product here should be +3. This one we can refer to our periodic table because aluminium is in group 3. Group 3 means it donates 3 electrons to become stable. So it should be +3, not +6. Number 3, the oxidation of copper in the reactant. Yes, here, because it's combined with oxygen, so if students can look at the periodic table, they can see that O is 2 minus because it's 2 and 6, so it needs to take in 2 electrons. So, and then they balance with 2 minus, that means Cu can only be 2 plus. Or we can just memorize it from our polyatomic ion table. And number 4, the oxidation number of copper product is 0. Yes, because outside here, copper product is not combined with any negative. So therefore, the charge is 0. So the answer is 3 and 4. Next question. Thymophthalate in dilute hydrochloric acid. So like basically, what is the color of thymophthalate when it's mixed with acid? So this one, students have to learn. So let me just pull out. So students need to memorize the color of this. All right, so let me just pull out a photo so that students can memorize. So this one here is very useful. So especially for exam students, do make sure to memorize this before going to the exam. So okay, maybe I zoom out. So thymophthalate. Sorry. Sorry, that one there's only phenolphthalein. All right. Yes, this one here. So students can actually memorize this. So thymophthalate is colorless below pH 9.3. So for alkali, it is blue. And for acidic, it's colorless. So this one over here, it is colorless. Okay, so to make it simple for students, just memorize, just write down in your notes, thymolphthalin acid is colorless, blue when alkali. Next question. Two acids, P and Q, with the same concentration and volume are reacted separately with the same magnesium ribbon. Okay, so there are two different acids, but the same concentration and same volume. So definitely, if there are two different acids, one will be more reactive than the other one. Okay, so they produce the same total volume of hydrogen gas, but one reacts faster and one reacts slower. Okay, so as we read earlier in question 19, there are two acids, but one reacts faster, one reacts slower. So clearly it means that one is more reactive than the other. And if the student have learned acid and alkali chapter before, they should have learned that within acid and alkali, there is such a thing called strong acid and weak acid. But if we look at the answer here, there's no like strong or weak acid. But the thing that explains strong acid is fully dissociate and weak acid partially dissociate. So so let's see here. Q reacts much more slower. So if we read the question here, Q should be lower. So Q should be a weak acid. And vice versa, P should be a strong acid. So clearly the answer is C because it fits the description. But let's just go through A, B, and donkey. Acid P has a higher pH, but remember for acid, you want the lower number. So this is opposite of what we want because acid P, if they just change this word to lower, then A would also be a correct answer. Boy, acid P has a lower concentration. Again, this one is wrong because P reacts faster, Q reacts slower. So if they just change this to higher concentration, that would be correct answer. Acid Q is a proton acceptor. This does not matter at all because whether it's a proton acceptor or proton donor, it doesn't tell us that who is more reactive. Okay, number 20, which process is not used in the preparation of an insoluble salt? So students, if possible, should have a exact step if we want to prepare a soluble salt and if we want to prepare an insoluble salt. So the best way here is to memorize, okay? But because insoluble salt, so the answer is crystallization. Why? Because we only use crystallization for salts that dissolve in water. And the name already tells us it's insoluble salt. It cannot dissolve in water. Why would we use a method that is only designed for things that dissolve in water? Okay, the rest all we use, whether it's soluble or insoluble salt, filtration, washing, drying, we use it for both. But crystallization is only when we have soluble salt. Anyway, let's move on. Lithium and potassium are group 1 metals. Which row describes the melting point and density of potassium? Oh, okay, so lithium is 181. All right, so we just need to know the trend. So this is one other thing that students should memorize as well. When we learn the different groups in the periodic table, you need to learn going down is the melting and boiling point increasing or decreasing. Same as well for the density. So density should definitely be higher. But just double check lithium and potassium. So lithium is up here. Let me just get the pen. This is lithium. Potassium is down here. So the density should definitely be higher because there's a higher amount of protons attracting in the electrons. So it's more packed. So it's either boy or donkey. And then for melting point, because the lower we go, the melting and boiling point decreases. So it should be less than 181. The highest one is the top. This one comes down to memorizing. There is also an explanation for it, but we will not go into it here because that one is more of notes. Students need to like write it into their notes. Number 22, which statement about transition metals are correct? They have a low density? No, they have a high density. Again, this is another memorizing thing. Okay, transition metals have the higher density compared to all other metals. Yes, they have variable oxidation number, high melting point, yes. They form colorless compounds? No, they are more famous to be colored. They form colored compounds. So the answer is C, only 2 and 3. Number 23 describes period VIII. So in case you are very confused on this, V means 5, and then behind there's 3. So 5 plus 3 is 8. So yes, they have full outer electron shell, which is group 8. They are unreactive metal. Well, they are unreactive is correct, but they are not metal, so it's out. They are monoatomic gas, yes, because they do not need to share electron, like oxygen, like chlorine gas. They are diatomic gas, out. So the answer is A. Should be quite simple, except for this metal here. That one is actually very tricky. They are unreactive is correct, but when they add the word metal, then it's wrong, because they are not metals. Number 24. QRST. All right, so okay, so observation with water. So if react with water, if anything can react with water, means it's highly reactive. So when this one has a fast reaction with water, T is the most reactive. And then R here, so let's look at number 1. R is the least reactive metal. That makes sense because everything that it mixed with, there was no reaction. So yeah, I think it's safe to say that it's the least reactive. T could be potassium. So let's go back at group 1. Potassium is group 4. It's neither the most reactive nor the least reactive. Let's come back here. But at the same time, okay, let's maybe check like that. When it does react with water very quickly, potassium. When it touch with steam, it does explode. It does explode here also. It's also highly reactive, which is potassium. So it is possible. So for now, we give it a tick first. S is more reactive than QR. No, because here, when it mixed with water, it has no reaction, while Q has a slow reaction. So in this case, Q already shows that Q is more reactive. So this is out. Number 4. Of course, we can check further on, but just from the test with water, we can already tell that number 3 is wrong. Number 4, metals generally react faster with steam than they react with water. Yes, because in steam, which is gas form, the water molecules move faster. In water, the water molecules move slower. So yes, that's correct. Let's move on. Number 25, metal X is a sacrificial metal. Okay, so this is the rusting one. Metal X does not act as sacrificial metal to prevent aluminium, but it does prevent iron. So what does that tell us? It's more reactive than iron, but less reactive than aluminium. So this one, students need to have the reactivity series. So this is another super important thing. So let me just grab a photo of this series. So this is just one example of the reactivity. Okay, it's rather big. So let's minimize it. Where shall we put it? Okay, so we put it here. So let's look here. It is more reactive than iron, but less reactive than aluminium. So the only thing between these two is zinc. So it has to be zinc. There's no other choice. But this series, this whole reactivity series, students should memorize the whole thing, all right? Yeah, because it's not provided in exam, huh? Okay, so that's that. So just memorize the list. Number 26, which equation represents reduction? So reduction, to memorize, very simple, is either it lost an oxygen or the charge, the oxidation number reduced. So looking at this ABCD here, looks like there's a lot of oxygen. So I think we start testing with the first one first. So who lost an oxygen? Hematite in a blast furnace. So let's see. A looks like it lost an oxygen, right? One moment. Because at first here aluminium is stuck together, but let's just continue first. This one does not look like it experienced any reduction because it still has an oxygen, especially the calcium here. But in the first place, when we are talking about hematite, it is not aluminum. I won't review it yet. This one is not because here it has oxygen. Here it also has oxygen. Here, yes, at first it has oxygen, stick with the Fe, but coming out, there's no more oxygen. So A and donkey both are correct. However, when we say hematite, what ore is this? Like what metal is inside hematite? Iron. Again, this is a memorizing chapter, so students need to have this memorized. Memorize all the different ores for the different metals. Then you will know hematite it only represents iron with oxygen. And then aluminium with oxygen is called bauxite. And students, please memorize all the rest. All right, let's move on. 27. Which statements about the treatment of domestic water supplies are correct? So, okay, let's read through. So, water supply filtration is remove the insoluble. Yeah. Sedimentation is used to remove soluble. No. Sedimentation is to also allow the insoluble to sink at the bottom. That means we leave the water there for a long time until all the things sink down. Then we just take the top part, which should be the clean part. Carbon is used to remove tasteless water. Yes. Chlorine is used. No, chlorine is used, but it's not used to lower the pH. It's used to kill whatever bacteria is inside. So the function is wrong. So yeah, answer is A. So students can also memorize this, right? Memorize everything about water cleaning. There's 4 steps. So students need to memorize what happens in those 4 steps. Number 28, which statement about water is correct? This one you have to memorize. You have to memorize. So there's 2 things that we use to test for water: anhydrous copper sulfate and cobalt 2 chloride. And also on top of that, students need to memorize how the color changes. So the only correct answer is this one because it's copper sulfate white to blue. Okay, but maybe yeah, okay. I don't think we have the time to take out the notes, all right? But yes, answer is B. All right. Memorize what color they change and memorize what is that thing. Copper 2 sulfate, cobalt 2 chloride, and copper 2 sulfate must be anhydrous. Okay, number 29. What kind of substance is capronickel? Okay, so capronickel they show us here. So clearly it is 2 different metals mixed together. What is that called? Alloy. Again, another memorizing topic. Alloy is a mixture of 2 or more different metals. Okay, let's move on. So good, it's easy questions. Which physical property are typical of all metals? So all metal have very good heat conductivity. Low density, no, because there's normal metal and there's transition metal. Transition metal has high density, so it's not for all metals. Malleability, yes, so it's 1 and 3. 31. Which oxide is used to neutralize acidic gases in flue gas desulfurization? So this one as well, we need to memorize in the chapter of what's that called? The heating where we extract metals, blast furnace chapter. All right. So do revise your blast furnace chapter. All right, but basically calcium oxide is used to remove the flue gas. All right, please refer to the blast furnace chapter. Okay, very important. 32, yeah, refer to that. There's a very clear chemical reaction, how we actually desulfurize the flue gas to take out the sulfur. Number 32, PQR. Gas P forms when magnesium reacts with dilute hydrochloric acid. Gas Q mix. Okay, so gas Q 78%, definitely nitrogen. Forms when magnesium reacts with hydrochloric acid. So we should get MgCl, right? Yeah, magnesium replaces the hydrogen. Oh, sorry, no, plus H2. They want the gas that forms, so it's the H2. And then gas R forms when gas P reacts with gas Q. So it's something combined nitrogen and hydrogen. So this one definitely ammonia, because the formula for ammonia is NH3. So like it has nitrogen and hydrogen inside. Yeah, so I think that's the answer. Okay, let's move on. 33. Which formula represents an alkene? ENE. So this one students need to memorize. ENE means that the formula is 1 to 2. Carbon is 1 ratio, hydrogen is 2. So answer can only be B because everything else is a different ratio. 34. So looks like the easier questions are at the back, huh? Two compounds used to make an ester. What is the name of the ester? Okay, this one here, students need to remember that the alcohol is always the name in front. So like here, how many carbon do we have? 2. So students also would have memorized that it's ETH when we have 2. And this one here is 3, and this one is the carboxylic acid, and it has 3, so met it prop. So it is prop. So this one comes first because as we memorize, the alcohol name must come first and then the carboxylic acid. So the only one that has ETH at the front and prop at the back is answer A. So the answer is A. 35. Which statement about the homologous series is correct? So homologous series means that they have the same chemical formula but the different structural formula. And also is important. So yes, this one here. Because it's the same general formula. Different physical property, but yes, they do have the same chemical properties. Show a trend. Not really. It's like, say, it's not showing a trend. They should have the same chemical properties. Same molecular formula, no. Because molecular formula is a different way of saying structural formula. So they only have the same general formula. So that is 35. 36. Which statement about ethanoic acid is correct? Contains the functional group COOH. Yes, correct. This is correct. All right. An example of ethanoic acid is this one here. So we can see that they have the COOH group inside. So yes, it's correct. It reacts with carbonates to produce hydrogen. Okay. There is specific reactions for every single group in the hydrocarbon. So students need to memorize whether it can react with hydrogen. So in this case, it's no. It's a no, all right? Oh, sorry, it react with carbonate, my apologies, to produce hydrogen. It turns universal indicator blue. Blue means that it is alkali. No, this is an acid. It should turn it red, not blue. It has a pH lower than 7. Yes, because acid does have a pH lower than 7. So the answer is C. 37. Alkenes react with steam in an addition reaction. Some alkenes produce only one alcohol product. Some alkenes produce 2 different alcohol, which are structural isomers. Okay, alkene produce only one alcohol product, and then some alkene produce two different alcohols. Okay, all right, so let's see what they want. Which row gives the number of alcohol isomers formed when ethene reacts with steam and when propene reacts with steam? The isomers. Ah, I see. So for this one, okay, one example is like C, C. So basically at first it has a double bond. And then here we have H, 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 H. So this is ethene. And then propene, it can have something like that. And then here, I'm not gonna draw it out, but they all have H here. But the thing with this propene is it can either be like that or it can be like that. That means the carbon can be sticking to the left-hand side or the right-hand side. And because it's a slightly different formula, structural formula, we call this two different isomers. Whereas this one, there's no way to change arrangement. So therefore, the answer is B, because this one has one arrangement, two arrangement. This one can only have one arrangement. So the answer is B. 38. What is an advantage of manufacturing ethanol by fermentation? So there is a chemical formula to this, so make sure to memorize. So let's start with A. No gases that cause global warming. Not exactly, because there is also like carbon dioxide from the fermentation. So not really. Ethanol that is produced is pure. Both produces pure ethanol. So it's not really an advantage of fermentation. Fermentation is a fast process. No, it's a slow process. On the other hand, the one that we do the steam, which is the man-made production, is much faster. So this is the wrong one. So fermentation uses renewable raw materials. Yes, that means we can keep on using the yeast and we can keep on reusing them. However, for steam, we will need to keep on buying new raw materials. 39. The diagram shows the structure of a polymer. Which one represents the monomer for this polymer? So notice the pattern here. So if students can pay attention, they can see that this is one group here. This is another group here. And this is another group. And if you pay attention, it should be repeating itself, the pattern. So which one is the monomer? One of this. So you just look down at the drawing, which one shows one of it? So it looks like it's A, because it's C and then CH3. So you can imagine this as one group and this as one group. So this one you see has CH3. Oh, hold up, but they have a double bond here, so looks a bit dangerous. Oh, yes, but when we say a monomer, the double bond always, it closes up, it opens up. So for example, like the basic one is like 18. At first, it has a double bond with carbon monomer. So like it looks like MON here. But once it turns into polymer, the double bond opens up. Then C, C, and then it joins the beside the two. Of course, that's a up and down. So here we must add on one double bond in the middle here. Is that logic? So the one that has a double bond being doesn't look like B, because this one here is supposed to be hold up a minute. So this tree is this tree here, and then CH, and then there's a double bond. But here there's only two carbon, but here there's three carbon, so it's not right. Looks like the answer is let's double check. So here is the CH, which is this CH here. And then this connected to a CH3, which is this CH3 here. And then here there's this H, which is CH here. And then there's C, O, and H. So the answer should be C. Okay, so the 9 is C. And the last question, which piece of apparatus is used to measure 4.5 cm cube of gas produced during a convection? So this one, so you have to memorize all the different apparatus we have in lab. So the easiest, I think, definitely not pipette, because pipette is used to measure the level gas. Conical flask will not be able to do it because conical flask is distinct. No. So the only one that can use to measure gas is actually measuring cylinder. But this is a bit tricky. Normally we do it like that, and then we have the liquid here, and then our measuring cylinder will be upside down, and we will measure how much gas comes out. So that's why it's tricky. So anyway, that's all for this plastic paper. Okay, so I hope this has helped you. So if you watched this one, please like, share, and subscribe, and follow our page to see more upcoming videos on. Thank you and good night. Bye.